All right. So today we're going to dive deeper into the programs Git and GitHub. And as you get deeper into the curriculum, you'll see sort of how we have things organized for each lesson. There will be a main README where we'll list out the lecture for the day. And we're going to try to have sort of a 1 hour block lecture and then assignment time and then another block lecture. And these are definitely worth reading in advance. We're also going to list learning objectives. Anything starting with a T is like a hard skill that you need to know and be comfortable with that is either directly tested in an assessment or you need to use in order to do an assessment. Anything with an E, these other learning objectives are more conceptual that are important, but not something that, say, is like directly tested. But obviously, understanding the essential Git workflow is something valuable and important. So this is definitely worth looking at and taking the time to look into. Again, the videos are on the main README for the whole repo for the previous cohort, if you want to look at that as well. For each lesson, also down at the bottom, there will often be resources. I do recommend, if nothing else, just taking the time to click on the resources for like 30 seconds and just glance at them because there's some really good stuff in there. And we'll do our best to provide sort of advice and cheat sheets and review. As we get deeper into the course, there will also be directories with code examples. Like there's not one in here for today, but as long as I'm sort of doing this quick preview, for tomorrow's material, there's this directory examples, and this has all the code we'll be doing in that lesson. And so keep your eye open for a directory named examples or code examples. So version control is really important for modern software development. There are several different tools you can use to accomplish this. Git is not the only tool or necessarily always the best. It is a good one and a pretty popular one. And if not standard, it's somewhat close to it. And it's also open source. So that's what we're going to teach. And version control is software that lets us track the changes of our source code, just like you can with a Google Doc if you all have ever looked at like the version history. It also helps us collaborate, and we're going to see how, and it's incredibly useful. It is not an easy tool to learn. It's more complex. It's definitely not entry level. It was actually created by this guy, Linus Torvalds, who also created the Linux operating system, the open source version of Unix that's become so popular. And he created it to help manage a remote distributed team of volunteers really working on Linux and open source. It's really important because even for junior developer roles, some level of knowledge with version control is just assumed these days. And most likely, folks will assume that the version control tool you have some familiarity with is Git. So today we're going to learn the fundamentals of how you're going to be using it for assignments every day and getting used to that workflow to see how you can save the code you write in a meaningful way with version control and send it to GitHub, how to link a Git repo to GitHub, and a little bit of how Git and GitHub works and how you can point your local Git repo to different repos on GitHub. We're going to look a little bit at branches as well with Git. We're not going to go too deep into that. And I just want to pause and see if folks have any questions before we keep on rolling. All right, let's do it. So I'm going to be writing code in a minute. There is just a little bit of preamble here. This is not the worst thing to pull up if you have a second monitor to kind of keep an eye on and look at. There we go. So you can do all sorts of great stuff with version control for source code. And as you can see, we use it for the curriculum itself. And I'll talk more about the difference between Git and GitHub in a little bit. The program Git is what we'll focus on. GitHub is basically this beautiful web app that gives Git an amazing GUI and stores Git repos in the cloud for us. So it's really common in GitHub to look at what's called a repository, and we have a number of them. If you go to our assignments GitHub board, where you'll be spending more time soon, you can see we have a whole bunch of Git repositories, and normally a repository is like a specific project, right? And just to pick one at random, you can see here sort of the layout. This right here is what's called the README. And the convention is you always have a file named readme in all caps .md. MD stands for Markdown, which is a special text format. You can actually see the source code like this. And GitHub will by default display the contents of that README when you go to look at a repo. What we're going to kind of focus on today, and the core idea of Git, is something called commits. And we'll see how to do this on the command line in a minute. But on GitHub, when I'm looking at a project, I can look at the history of the different versions of that, and each commit is a change. And so I can click there and I can see all these commits. And a commit might be just one file. Like here, you can see I made a very small change to one line of code in one of our files. Or a change, a commit can be a change to a whole bunch of files. And like you can see here, Francisco made a change to many, many files. And GitHub is, we'll learn more about this later, but doing its best to give us a graphical user interface where you can see sort of over here on the left is the old version, and anything red has gotten deleted and anything green has gotten added. And so this idea of a commit of a change is really simple, but a commit can be tiny or huge for a whole bunch of files, right? It doesn't have to just be one file. And I want to check in and see if that makes sense and if folks have any questions. Cool. So we're starting to get the idea of version control as letting us create commits that give us a timeline of history. We can look at a specific commit. And again, we're going to see very soon how to do this on the command line. You'll notice this number here. And if you look up here, there's also this number here. This is a unique alphanumeric string, numbers and letters, right? Called a commit hash that uniquely identifies these changes. And this is kind of a little bit of under the hood of Git of how it's organized and keeps track of stuff. So the basic idea of version control with Git is I do a little work, I commit that work, and then Git adds a commit hash, and that's how it tracks each of those changes. And then we have this really nice timeline and history that we can see. So I am going to go back to our curriculum doc for a moment, and I'm just going to open up this image in a new tab because this is a good one. And everyone can see this giant image that says local and remote, correct? Perfect. So local is the term for your own computer, local dev, right? Local environment. Remote here basically means anything that's somewhere else. It is going to be almost always, and always for the purposes of this class, the remote Git repository that we care about is the one on GitHub. So GitHub has, a bunch of virtual servers in the cloud, and you can literally think of it as like virtual Linux boxes, like virtual computers running Linux in some data center. So we don't have to worry about if it's a real computer or not. These days, the magic of sort of data centers and virtual machines takes care of that. And there's a Git repository living in the cloud, and we'll talk more about what that means in a minute. So this Git repo right here Code Platoon curriculum, right? I can make a copy of this on my own machine. And many of you have probably already done this. If I wanted to make a copy of this, this is called cloning, and we'll kind of go into it more later, but just to sort of drive this idea home, right? I could copy this depending on how I authenticate it with GitHub, HTTPS, SSH, or with the GitHub CLI GH. So you do want to know how you authenticated. I could go ahead and copy this and run this on the command line, and it would create a bunch of directories, including a special Git directory that has a copy of this. And indeed, I do have a copy of this. If I go to and let me actually see if I can't bring my other window to the fore here. Yeah, we'll bring this one to the fore because I already have it up. So that's why GitHub is kind of doing this. And actually, by the way, as long as we're talking about this, something very useful to know, any markdown file, if you do Command-Shift-P on a Mac or Control-Shift-P on Windows to open the VS Code command palette, when you're looking at a markdown file and you start typing preview, you can get a nice, friendly preview of the doc. You can click on these links. So I can click on the lesson, I can scroll down and I can see the images and stuff like that. So I've got a copy of this code base, right? Of this project, our curriculum project, of this Git repository on my local machine. And Git is the tool we use to keep these things in sync. So I just want to pause here and see if folks have any questions as I'm kind of going through this sort of background and preamble and going through concepts. And any and all questions are good. Remember, the rule of thumb is if you're wondering, there's probably at least 5 other people wondering as well.
I had a quick question.
Yes, sir.
So out of the like HTTPS and that the other options on there, are there like advantages to either of those, or like if I want to download it to my machine, which one should I be looking to get?
Yeah, that's a great question. To be honest, you should be looking to get the one that you can have set up and working the quickest. It doesn't make a huge difference. SSH keys are used for all sorts of different authentication things, not just Git, so that's valuable to learn, but it's not worth making that a blocker right now. On the Install Fest, we encourage people to use the GitHub CLI program GH because it's fast and straightforward and gets it working. So if you're not sure, I would recommend that. And then you can another day learn about like SSH keys and how to set that up and stuff, because gets a little trickier. So I would just use the GitHub CLI. Great question. Do folks have other questions around like authenticating? Or questions about anything else?
I have a question about the auto completing that you did with the tab to get like the code Platoon curriculum. Is that something that was supposed to be set up yesterday? I know it was on the homework, but I couldn't get it to work.
Oh, great question. Do you mean on the command line here?
Yes.
Got it. Yeah, great question. How's the font size here? Okay. Should I bump it up a little bit?
Looks good.
Cool. All right, I'll bump it up just a notch. Yeah, so great question. So tab auto completion is something that should work out of the box in your terminal. I don't think it should matter whether you're using ZSH or Bash as your shell, though I think everyone here should now be using ZSH. If I want to navigate to a directory with CD, and actually let me go to my home directory, where I have a bunch of stuff, because I just want to find a couple things that start with the same letter. Like here, we've got a bunch of Ds. So if I want to navigate to some directory, let's say I want to get to downloads, but I don't remember its name, and I hit D and I just hit the tab key, it will give me a list of all these options. And as I type, I can hit tab and it gives me more options. And I hit W and I hit tab and there's only one. And then I'm good to go. That should be working for everyone. That's like a core shell feature. There shouldn't, even if we hadn't done install fest, I believe that would still be working. If you are on the command line and kind of typing something out and hitting tab and nothing is coming up, it may mean that you're not in the directory you think you are, or that there's a typo. And that's actually why I do it, because I make mistakes all the time. And so like if I'm looking for, I don't know, the Zebulon directory, and I'm typing Z and hitting tab and I'm seeing nothing, then that tells me, Adam, I may have ended up in the wrong directory here. Let's do ls and pwd and make sure I'm in the right spot. Does that help a bit?
Yeah, I'm gonna try when we get a break, and if I'm still having issues, I'll just come up online.
Awesome. Let me go ahead, actually. Actually, folks, if someone, we'll get like a question stack up, but if folks do have other questions, maybe just shoot them in the whiskey channel for now, and I will make sure to circle back to them later. So let's start doing stuff with Git, and let's start creating a Git repository. We've kind of talked about what it is, this idea of we're going to have a local instance or copy of a Git repo, and then we're also going to have a remote instance of that same Git repo on GitHub, and they can talk to each other and be in sync. So let's start digging into this and breaking it down. We're going to encourage you all to primarily use Git on the command line. There are a lot of GUI, graphic user interface tools out there for it. Some have value, some honestly are confusing. And while the command line is not the be all end all of programming, some degree of comfort with it is important. So that's kind of why we push it in the course. So Git is installed just like any other command line program. And we can do everything we want to pretty much with Git from the command line. There is also the GH GitHub CLI, which I probably should use more, to be honest. It's just a bit of a newer tool. And so I just have so much muscle memory over the years from using Git. GH, I would use it to authenticate if your authentication isn't set up. Otherwise, I would use Git for most stuff because that's what we have in the curriculum. So you can kind of be on the same page with everyone else. So as you notice with most of these command line programs, when you just type it out and hit enter, you see a list of like core commands and usage and stuff like that. And there's always the -- help flag as well. And I can always do help and pipe it into the less program so I can paginate through it. Let's go ahead and see how to make a new Git repo on the command line. Let me go ahead and navigate into the directory where I keep all of my work. If you don't have a directory named code or projects or code platoon or whatever you want to name it, I highly recommend making one now, and name it whatever you want. And I made in there a directory for whiskey, and in there I have a Git fundamentals lesson. But let's say I want to go ahead and create a Git repository. So the nice thing about Git is it plays nice with the file system. So let me just go in here, and I'm creating a new project from scratch. I want to create a directory with makedir for that project, and we'll call it my first repo. And now I'm going to go ahead and navigate into that directory. And there's nothing in it right now. If I do ls space -a, it'll list all directories and files, including the dot files. And right now, there's nothing there because we just made it. So git init, which is short for initialize, as in create, is the command that we can use on the command line to create a new repository. And we get this statement, initialized empty Git repository. right where we are, which is great. If I'd given it a file, a path to some other directory, it probably would have made it there. And now something interesting has happened. If I do ls space -a, I see there's a new directory here named .git. And that's actually the Git repo itself. And you can actually go inside it and look at stuff. You shouldn't. There's very rarely a reason you need to go inside there. But it's useful to know everything that Git does, it stores inside that directory. And now if I use this command git status, it will tell me the state of my repository. But if I navigate outside of this directory, right, I'm no longer in the my first repo directory. I'm in the Git fundamentals directory, and I type git status. I get this message fatal, not a Git repository or any of the parent directories .git. So what git status does is it tells Git, look in this directory for the .git directory that says this is a repo. If it's not here, look a level up until you find one. So Git is super simple. You just have to navigate to the directory that has that .git file for your repo. And the easiest way to do this is, for each Git repo and each project, you've got one directory. And then when you're using Git inside that directory, it's for that Git repo. So if I navigate back into my first repo and do git status, then I get my message. So I just want to check in and see if that makes sense to folks, and if folks have any questions about stuff.
Can I ask real quick, what was the Git in it? It was just creating a repository?
Exactly.
Okay, thank you.
Yep, for sure.
Something that I've noticed just from my experience using VS Code after having Git installed, sometimes I'll end up in like my home directory, and then my source control will say there's thousands of changes. Is that because there's a .git folder on my home directory? Or is there a way to make it so that, like, in my home directory, obviously that doesn't need to be attached to GitHub. And I feel
It
like
sounds like there is a Git repo in your home directory. Yes. Like
so
you
to
probably
stop
don't
that,
want.
would I just delete the .git folder?
Exactly. Yeah. And actually, that's a great thing to mention, and let me demo that now. If I do rm space rf.git, and just, and this wouldn't delete anything else in here. And now I do git status. There's nothing there. By the way, note that like the command line shifts a bit. It tells me the branch that I'm on when there's a Git repo present. So, like if I navigate to my home directory, and if for some reason, like, if I do git status, there's no repo there. And if I do git init, if I do git status, if I scroll way up here, we'll talk about what Untracked is yet, but it say, hey, cool, you created a directory. There's all these files and stuff in it. What should I do? Well, if I don't want this, I can just do rm space rf.git. Just make sure that you're only deleting that .git directory. All my other stuff is here. There's no longer a Git directory, and I'm good to go. Yeah, and that's a really easy error to make, and it's why it's important. I think when you're working on the command line, you should be basically typing pwd like every other command to make sure that you're where you think you are. Like pwd and ls are your best friends. So let's explore more of what we can do with Git now that we've made a repo, because there's not a lot that's interesting right now. I think the one thing to mention briefly, and let me go ahead and clear this, is that it tells me what branch I'm on. Main is the default branch that I've configured Git to make when it creates a new repo. For most of you, it will be main. For some of you, it might be master. That used to be the default name. And we can also see the branch name here on our command line prompt. And we'll talk more about branches later. So let's go ahead now and start looking at commits and how we add stuff here. I'm going to use VS Code to create a couple files. So, we all saw yesterday how I can use this command to open a file. If the file doesn't exist, this will also help me create it. And for some command line commands like touch or create directory or code, you can pass it more than one thing. So I've just opened up 3 new files. And note, by the way, VS Code gives us some icons and hints here about stuff. I'm honestly not sure what this blue arrow thing means, but I know for sure this black circle means that this file is not saved. And if I do ls, none of these exist yet because I need to save the file for the very first time. And there's this message that VS Code gives me, but since we have the file type in the file extension in the file name, I can just save the file. Black dot is gone. VS Code has figured out it's a text file. Now it exists. So I'm just going to go ahead and save each of these. And now I've got 3 new files. And now if I type git status, I get something interesting. Untracked files. So the deal with Git is there's 3 states that a file or directory can be in a Git repo. Untracked, staged, or committed. And as the name committed implies, once something is committed, it becomes a Git commit and it's saved in version control. And we can like it's even if we deleted it, Git would still keep track of it. And I'm just going to quickly sort of reproduce this diagram that we have in the lesson so we can actually kind of play with this as we go. And my committed rectangle is a little small, but that's okay. And I'll use, I think, just smaller one. So we've got, right, our text file. Our Python file. And it helped if I spelled the name right, and our JavaScript file. And while I'm doing this, I know that some folks have some experience with this already. So maybe could someone who's already spent a little time with Git and GitHub sort of give the class, like, what's the high level rundown? Like, what is the difference between untracked, staged, and committed? Or if this is all brand new, then all the better.
I think like untracked means you haven't yet told Git to even like look at them or care about them. And that would, you'd need to type a command to do that, which I think would be add. At that point, Git would know about the files. And it's like being on deck to be committed into the version history, but not quite. Once you're sure you want to commit them, you can go from stage to commit by typing commit.
Yeah, that's a great description. And I know someone else was going to say something else.
I was just saying that there's like you gotta realize the difference between the local and the remote being up in the cloud. So you kind of are pushing along this path in your local environment to a point where you end up pushing it up so that things can be committed locally, but then you have to actually push those up to the remote instance.
You're absolutely right. And we're going to get to that a bit later. In terms of just sort of the different states that a file or directory can be in Git, though, we don't have to worry about if it's local or remote yet. We're going to come to that a bit later. All of this is just for our local repo right now. So basically, once something is committed, even if I like deleted that file, Git still has a record of it and I can get it back. When it's untracked, I delete it and it's gone forever. When it's staged, Git will keep me from deleting it and kind of give me a warning. So untracked is no protection, staged is some protection, and committed is full protection. So let me go ahead and actually do some of this so we can see it in action, and then I'll kind of check in with folks and see what's on people's minds. So the command we use to stage something is add. And one metaphor to think of here is like baking like some cookies, right? The way I think about it is, and I think I'm gonna go all in on this cookie metaphor and maybe use the color green. Like one way that I sort of think about it that I kind of like is once we make a commit, the cookies are baked. You know, they're done. They're cookies, they're baked. We cannot like form or shape the dough anymore, or cupcakes if you prefer, or like a cake, maybe something that you can change. But this baking metaphor of multiple things. When we stage something, we're adding it. We're saying, hey, we're gonna bake the cookies. And untracked is like dough in the bowl or something like that. You know, there's no shape or form whatsoever. And the command we use to add a cookie to the baking tray to stage some sort of change that we made is the add command, git add. If I do -- help, there's all this stuff. It brings up the man page for it, add file context to the index, and there's all this stuff going on under the hood with Git that we don't really have to worry about, and we can pretty much ignore. More so, I just wanted to show that this exists. There's a bunch of command line options that we don't have to worry about right now, and I can hit Q to exit that man page. And for the git add command, you can pass it a directory or multiple file names, or one file name. So I'm going to add the JavaScript file. And if I hit tab, we've got a lot of examples. So I'm going to add the JavaScript file. And now if I type git status, I've got something interesting here. It says a change to be committed, example.js, but these two are still untracked. And let's actually do a very quick Google search and see what protections we get with git add. What I actually want to ask, and we can just try this out in a moment, is can you delete a staged file? Well, let's see actually what happens if I do rm example.js. So something interesting here has actually happened. I deleted that file, but it still says changes to be committed. Git has still protected that for me. And now there's a change not staged for a commit, actually deleting that file. And if I type ls, it's gone. There's this interesting message here, and it is worth taking the time to read through the little kind of helpful hints that Git gives you, because it kind of tells you how to undo stuff. And it tells me, hey, you may have staged or added something, but if you want to unstage something, you can use this git restore command. So if I do git restore example.js, let's see what happens. I just undid that I want to delete stuff command, and lo and behold, that file is back. So I thought this was the case, but I did want to double check. When you stage something, Git protects it from being deleted. It's not like full-on protection, but you get some protection. But, you know, if I had deleted example py, which is untracked, that file would just be gone. And Git doesn't compare, or excuse me, Git doesn't complain at all, because Git doesn't do anything with stuff that's untracked except tell you that it's untracked. So let's go ahead and add the other files. Let's stage them. If I use the dot command, this is a shorthand for the current directory. If you all remember from yesterday, like cd dot dot moves you back. If I do cd dot, it just takes me to where I am. Dot is like a symlink or an alias for the current working directory. So git add dot will stage everything that is untracked in this directory. So it should stage both of these other files, our Python file and our text file. And most of the time, just doing git add dot can make life a little easier. Though it's a good habit to be more specific, but I do use git add dot all the time. If I do git status, I see now that these are the changes to be committed. And let's go ahead and bring these guys over to our staging area. And Git doesn't just track creating files, it tracks changes to files. In my text file, if I add hello world and save it, and I type git status, it says, hey, one of these files that I'm now tracking that I've added has changed. There's a great command, diff, that will show you the difference for something. And this is a little weird to read, but this is showing me the change between what's staged and untracked. And it's this hello world message. And if I like make my commit now, hello world will actually not be in that commit. But I'm not going to worry about that for now. I'm just going to go ahead and delete that. And now if I type git status, we've got all this stuff. It says we're ready to go. Let's go ahead and make a commit. So a commit is when the cookies are baked. It's when it's added as something in our version control history. It represents a unit of work in Git. Our install fest should have set it up so that when you run git commit, you get this editor window in VS Code. If you don't get this when doing git commit, let me know. There's also an easier and faster way to make commits that I'll show you in a minute that you'll want to do most of the time. But this is sort of the full process. So everything here with the pound sign is commented out. I created files, and in fact, I'm just going to uncomment those lines because that's nice to have in the commit message. And if I save and quit this sort of VS Code tab or buffer, down here, that commit, the little waiting has gone. If I do git status, it says, hey, we're great because this stuff has been committed. It's no longer staged. And now if I did say delete my text file and do git status, again, I would get this message, not staged for commit. Example.txt is gone. But if I use this git restore command, it will unstage that change. And bring that file back. So once something is committed, it's saved for good. And let me very quickly demo this with adding some comments. And then I think let me take some questions and then we'll move on. So let's say we wanted to add hello world to example.txt. And I'm not going to visualize this in TLDraw for the purposes of time. But I can see there's a change here. Something that we're not tracking. if I type git diff, it shows me what has changed in the file. I can diff a specific file, and there's no change for my JavaScript or my Python file. I can go ahead now and let's just git add example.txt to add that change. If I type git status, now that change is staged, right? Actually, I'll just put hello world here, right? For example.txt. And now let's go ahead and commit. And let me show you the other way to make a commit. That's a bit easier. Use the flag -m. This is short for message. And then in double quotes, just put the message you want to say. For now, just for learning purposes, try to have it be informative but short. By the way, the best practice is lots of very small Git commits. You don't want to make like 20-line Git commits. You should be making like 3 to 5-line Git commits. And now if I type git status, my working branch is clean. Hello world is in my text file. And in fact, if I say deleted it and I said, you know, goodbye universe, and save that, if I type git status, something is changed, right? We're adding goodbye universe and we're deleting hello world. But if I change my mind, because this change isn't staged and it's certainly not committed, I can use this restore command to discard that change in the working directory is just what Git calls like the actual file system and the directory that we're in. I can do git restore example.txt. And before I run this command, folks, if you can just pay attention to this example.txt file, and what do you think is going to happen to this example.txt file once I run this git restore command?
Go back to the way you had it before.
Yeah, exactly. And there we go. Right, very cool. So Git is great because it works with the file system. It will change the file system for us. But as soon as I make a commit, that commit is saved in this .git directory. So it's safe as long as I don't, delete the whole repo. So I could delete stuff and change stuff, and I can like restore. And as we'll learn with branches, it gets just more and more powerful. Athena, great question. Is this happening on my local computer or on the server? Everything I'm doing right now is on my own laptop. This Git repo only exists on my laptop. It doesn't exist anywhere else. And all the code I've been writing is on my own file system, and all the changes are there. So Git is just a program running on your computer. And then when we connect it to GitHub, it talks to Git running on another computer in the cloud. Does that help? Awesome. Yeah, great question.
I have a question, Adam, or just kind of clarifying.
Yeah, totally.
So like this is really like essentially all we're doing is continuously saving and updating the whatever file, whatever stuff we're working on in a hidden folder, and it's saving all of those changes that we want it to save, right? Like that's really all we're doing in essence.
It is way more than a hidden folder, though it is using text files.
Okay.
Because, like, let me go ahead and show a little bit more. That's a great question. But you have the right idea. Git is saving everything in text files, but it does it in a very, very structured way that gives us super granular control over stuff.
Okay.
And then the magic is obviously connecting it to GitHub, where I can, like someone else was saying, all of the stuff I've committed, I can send to GitHub so it's saved there. And then you can loan that project from GitHub. And it's not that you just get this code, it's that you get every single commit and that whole history in a saved controlled fashion.
Okay, gotcha.
Yeah, great question. So let me go ahead and make a bit more of a complex commit here. So let's say that I'm adding it's sunny out, and I'm adding example py. And if I type git status, I can see these changes. If I type git diff, it tells me the changes for each file, though this is a bit messy. There is, by the way, VS Code has a built-in version control sort of GUI thing. I mean, it's over here. It's this thing that's sort of, it's supposed to look like branches and commits with the lines and the circles. And you can see, you know, it's okay, not great. You can see changes. There's this button commit. There's a very cool visualization tool I'll show you all in a moment. There are some GUI tools that are okay. There's one called Git Kraken that some people like a lot. I do recommend trying to get comfortable with this workflow on the command line, and you might want to like draw some stuff out on paper, because once you get this basic idea in your head, then you're good to go. But it does take some time and practice. And again, this is not really a beginner tool. This is a pretty complex tool. The command line interface is not friendly. Frankly, even among programmers, Git is kind of notorious for its commands being a little arcane. However, it is as close to an industry standard as there is. So it is really valuable and important to learn. So, and in fact, let me go ahead and do some splits while we're doing this so we can look at maybe all of these files at once. So let me right click here and let's do a split down. I always get confused about which way to do the split. Split left. And let's go ahead and split this one. And let's put the text file there. And let's put, the Python file there. And we'll split this one like that. Okay. So, and this is why VS Code is your friend, because right now it's not a big deal, but once you have more files, it's really nice to be able to lay stuff out like this. So, and I'm pretty sure, by the way, that like, here, let's get rid of, let's actually open the JavaScript file. And VS Code kind of gives you hints, like this JS says it's a JavaScript file. There's probably some icon saying we've got unstaged changes or here. But so again, as a reminder, I've changed my text file and my Python file. There's nothing in my JavaScript file. So let's go ahead and add these. For this one, I'll add both of these changes. So I'll just do git add dot. And now if I type git status, right, I have staged this it's sunny out and this hello world that I've added. If I type git diff, I don't think it'll actually show me a diff. Oh, it still does. Perfect. So I can see what I'm changing. That was a typo, I apologize. And let's go ahead and commit these changes. Add Python message and say it's sunny out. Awesome. Let's go ahead and add something to the JavaScript. Git status is your best friend and you should be typing it all the time. Git add dot is probably the easiest way to do stuff. Make your changes, make your commits really small. It should really only be like a couple lines of code. And now I've got these commits. So this is where it gets a little interesting. There's a great command, git log. And this shows me my commit history. It shows me these unique hashes that identify this commit. and it shows me all of my messages and stuff. There is a great extension. Sorry, wrong sidebar. Git graph. That I will. If you just search for Git graph and extensions, it should be the first one that pops up. You can see here it's got 7 million installs, so that's the one that you want. I do recommend installing it. And the reason is, once it is installed, you can use the command palette with Command-Shift-P or Control-Shift-P, and you can type git graph and view git graph, git log. And this, I've set this to this VS Code to be in the curriculum repo, so it's showing something else. So let me actually just reopen this. Sorry about that, folks. Let's try this one more time. And I'm just going to be very quick. And we had text file, the Python file, and the JS file. So over here, I need my JS file. And that was Command P or Control P for the file search. And so my terminal's here. I'm still where I want to be. Now let's try Command-Shift-P or Control-Shift-P and do a git graph. There we go. So here we see our commit history. And if I click on a commit, I see more information, and I can actually see the change to the file itself. Just to demonstrate the power of this is more advanced, and you don't need to be doing this. So I don't want to open this door too much, but let's say for whatever reason I wanted to go back in time. I can use this command checkout and give it a commit hash and take my whole repo back to that moment in time, but all that other work is still saved. And so that's why Git is more than just sort of saving stuff in a text file. And if I type git status, it says head detached, which is not worth talking about right now. We'll talk a little bit about head in a moment. I'm about to talk about branches to explain what I just did to go back to where we were. But that's really the power of Git, that these commits let you go to any point in your whole code base where you've made a commit. And we're going to look at branches in just a minute, where you're going to see you can like make variations and stuff. So I just want to pause there and see what questions folks have and catch up on the chat as well. So what's on people's minds?
Adam, I got.
go ahead.
Yeah, sorry. I got one question about when you write the git commit and it opens up in VS Code. Is it taking the first line above all the other lines as the commit comment?
Oh, great question. Yeah. So if I do, let me just. Right. So I just created a file and added it. This pound sign, it means that this line is commented out. So we can write whatever I want in here. In fact, it's not uncommon for people to write like paragraphs describing a change if it's something more complex. The most important thing, I think, is for it to be useful. If I uncommented this stuff, it would show up in the commit message. As you can see. Good question. And I know someone else had a question as well. And while I love being informal, since we have a bigger class, let's actually use the Zoom hand raising thing, because otherwise I know it is going to be hard for folks will inevitably just talk over each other. And if I miss someone's hand up, just remind me or just speak up. Yeah, David.
Yeah, apologies. I missed the Git graph. Can you walk through that real quick again? Sorry.
Yeah, for sure. So in this sidebar in VS Code, go to extensions, which is these sort of like blocks, like Lego blocks type thing. And here, search for Git graph. It is almost definitely the first response, this extension. You want the one that's got almost 7 million installs, and just hit the install button and it should be good to go. And then what VS Code is doing is it looks at the directory that you've opened VS Code in, what it calls the workspace, right? So you can look at your Explorer to see what the root directory of your VS Code workspace is. And the easiest thing is to make sure it's the same thing as the root directory of your project. And you always want your Git repo to be in the root directory of your project. And now if I use the command palette with Command Shift P, and I type Git graph, it just shows me that visual tool. You probably don't need this very often. It is one of the visualizations of what Git is doing that I think is actually visualizes it well. So that is why I do like to demonstrate it. And actually, it can be great as a learning tool. So I do recommend installing it. Brian, yes, sir.
Earlier, we talked about deleting a Git repo, if we find one that's in a weird place. But if we do that, if we have like changes or, different branches, is it true that once you delete that Git repo, the current state of the files in the directory are what you get after that? Like, so if you were at a checkout to a different version or earlier version or a different branch, well, once you delete the Git, you got what you got. Is that right?
That is correct. You usually don't want to delete a Git repo unless you've created it by mistake. That's also why the real power of Git is when I connect my local Git repo to a remote one. Specifically, we're going to connect it to GitHub, and we're going to do a little workshop time, but then later in the morning, we'll see then like we can push these commits up to GitHub, and then they're saved there safely in the cloud. And even if I lost my entire laptop, I could clone down that project and have my whole code base in version control. And yeah, you're absolutely right. If you delete that Git repo, all that stuff is gone unless it's saved up in GitHub. So you don't want to do that. And actually, this raises a good point. Most of the programming you all will do in this class, like you should be trying stuff out and kind of like not being afraid to break things when writing code. Because, there's not a lot of harm that you can do. The one thing that you can really paint yourself into a corner with is Git. Don't do stuff with Git if you don't know what it does. And I know that that's challenging because we're learning this. So let me say that again. Don't do stuff with Git if you're not 100% sure what the command you're running does. That's when you 100% should reach out to a TA or Francisco or myself. And the reason is it is very easy to mess stuff up very quickly where it becomes much harder to untangle. Like if I create a Git repo in the wrong directory and I add stuff in there, or a classic challenge is someone creates a Git repo inside a Git repo and doesn't realize it for like a week or two. As someone mentioned by mistake, I made a Git repo in my home directory. Git is the one thing where I would say the 20-minute rule is more like the 5-minute rule. Because as you all have learned with InstallFest, like system config stuff can get a little hairy, especially if you start going down a wrong path with it. So please reach out much sooner than later with Git and GitHub so that you can get some help, because it will just save you hours of your life. And David, Saul and Tyler, I see you guys have your hands up. What's
I
up?
forgot to lower my hand, sorry.
No, you're good. Cool. Okay, let me talk a little bit about branching, and then let's take a break and do some work time, because we're trying to make sure that we kind of take a break every hour. And I love the questions. Please just throw any additional questions in the Whiskey channel, and I'll be sure to follow up on them. So we've really walked through the core idea of Git, which is making commits and the 3 states that a file or directory can be in Git. Because by the way, I could make a directory and put a file in it, and I can do the exact same thing. Git doesn't really worry about if it's a file or directory. Again, I recommend make really small commits, like 3 or 5 lines of code. So everything inside our Git repo is in one of these 3 states: untracked, where there's no protection and the cookie dough is just in the bowl; staged, where we've like formed stuff into a cookie and it's on a baking tray and we have some protection; and committed, where now the cookies have been baked, it's fully protected, the dough can never go back to becoming a cookie, and that cookie will always be there. We've looked a bit at the commit history, and I do want to briefly look at this Git graph again with Git log, just to talk a little bit more about what's going under the hood with Git, because that's useful for branches. So remember, Git status is your best friend. Git log is your best friend, and that shows the commit history. And if I do Command-Shift-P and Git graph to view the graph, I can view this graph as well. And the cool thing about Git is that each of these commits only needs its own little change. And what Git does is it just adds all those changes together, sort of like Lego blocks building on top of each other. And you can see there's this symbol here, and this is a branch symbol, because what we're going to see is I can branch off of this, get all my work and all my commits, make changes on a new branch, but have this branch stay safe and untouched. And so Git sort of does a connect the dots kind of thing going on here. And the way that Git keeps track of this under the hood is with something it calls the head, which is the head of the branch or the most recent commit. And that's this guy up here. And in fact, if I hover over it, I can see this commit is included in head. And you saw when I ran, like, when I checked out, if I wanted to go back in time by grabbing a commit hash and checking out a previous version of my branch, Git says I'm in detached head state. And this little graph has changed, and this commit that I checked out is in bold. It's telling me, hey, like, you're not on the most recent commit on this branch. You've detached that head and moved it back in time. We've wound back the clock. If I wanted to, like, I could actually change stuff here and like then make a new branch, and all that's a little more complex that I'm not going to go into now. And then if I want to go back, what I can do is check out and give it the name of a branch, and we'll say, hey, let's look at what's the most recent commit on this branch. What's the head? That's where we want to be. Let's go rebuild that. And now I'm kind of back to the main branch. So let me go ahead and actually create a branch. So I've been talking a lot about branching, but I haven't done a lot with it. And this is where Git is a little arcane, because to create a new branch in Git, I use this command checkout, but I have to pass this flag B, which is short for branch. And then I give it the name of the branch I want to create. And now if I type Git status, it says my feature. And let's go ahead and add something to my feature. Let's open up example.js. example py and example txt. And for example JS, let's say our feature is we're going to add an it's snowing message. And by the way, folks, if I ever start jumping around Windows or VS Code tabs too quickly, just let me know. For Python, let's say for our feature, we're adding a it's snowing message to the Python file. And for the text file, let's say we're modifying a line of code that already exists. So let me go ahead and type git status. It tells me what branch I'm on. It tells me the changes I made. I could use git diff to look at those changes. If I do git diff example txt, it shows me, it's a little hard to read, but this stuff that's sort of in red is what is deleted and being replaced, right? It's replacing it's sunny out with it's snowing out. And if I wanted to, I could diff, and diff is short for difference, looking at the difference, the other files as well. But I'm just going to go ahead and add them. I'm going to make a commit, add my feature snowing. Now, if I type git log, it shows me the commit history here. If I go to git graph, we sort of see this thing branching off. Let's make this a little more interesting. Let's open up some directory foo, and inside there should be, oh, it's some directory bar. So let's open up that file bar and let's just add a message. It's snowing here too. Let's save that. I'm going to use the move command to rename bar to bar.txt. And I'll open it back up. Oh, I see what I did wrong. Excuse me. Actually, I'll just use Command P to open up bar.txt. I recommend getting comfortable with Command P or Control P if you're on Windows, and the VS Code keyboard shortcuts. And now if I type git status, something has changed. A file has been deleted because I renamed it. A file has been added with that text. Let's just go ahead and add stuff and add commit, more snowy features. And it's a little hard to see here. I was actually hoping it would show the branching a bit more. Maybe let me try adding like one more thing and see if it shows up better. Otherwise, we'll just move on. No, it's sort of combining everything. We're not quite getting the cool visualization that I wanted. But what's happened here is, and I am gonna borrow a visualization, I think, from the curriculum. Or let's actually just build it up here. If each of these circles represents a commit, when I branched, I built off of those old commits. So for instance, if I check out, and let's go to, let's do some splits so we can watch this happen. So I've got all these files that I've changed. If I do git checkout main, what do you all think is going to happen when I hit enter?
It's going to go back to, oh, sorry, I didn't raise my hand, but
No, it's all
gonna
good.
It's going to go back to main before it was branched out.
Yeah,
So none of these changes.
exactly. And now if I do git checkout my feature, I get them back. And in fact, if I use dash, that's a shorthand for jumping around. So this is where Git starts to get interesting. And what this is useful for is, say you're working on an assignment or an assessment and you want to try something out or you want to change something, but your code is already working and maybe you're worried about messing up what you already have. Well, I'm sure many of us have probably like saved multiple versions of the same like text document when we're writing something like version 1, version 2, version 3. You can use branches, right? And so like if I have my code working, but I feel like, man, I feel like my code is a little ugly. I want to make it better. I want to add this new feature. Let me check out a branch off of my main branch and do that work there. Because as you all will very quickly discover, the real enemy is programmer error. And so like whenever you have code that's working, you never want to mess that up. So I can create all the branches I want and do whatever I want. And nothing, the branches stay independent. So that's and of course, when I connect this to GitHub, all those branches I can push there and save there too. So that is a huge amount of the power of Git. And the last thing I'll show, and then I think I'll walk through the assignment and then we'll break and have some work time, is merging. Let's say that we like our feature and we want it on the main branch. So let me type git status. I'm on the my feature branch. Let me check out main. Merging is exactly what it sounds like. It is going to combine branches. All those commits we made on our my feature branch are now going to be added to the main branch. So if I look at the Git graph real quick, let's look just at the main branch. This is all we have. Let's watch what happens as we merge the my feature branch. Now, all of a sudden, all those commits from my feature got added to the front, right? On top of our previous commits onto main. And now we have all those changes here on main. And if I do show all, yeah, I was hoping we get the cool diagram. You see stuff branching out, but we don't. And that's fine. And so, and we still have the whole commit history of each little change. If we need to like go back in time for any reason or look at something, or if I just need to be reminded of why I did something. So this is really the power of Git. You're not going to do tons of branching now, but it's really good to see. And again, I would use branches for experiments. Try to keep your main branch code as clean and as simple as possible. Actually, another really good use case for branches is, I know a lot of folks don't like to always delete code, even if it's old. And you all will probably hit a point where you have a lot of old commented out code that you feel a little uncomfortable deleting. I will do stuff all the time. Like, let's say I've got, you know, let's use the Python file. let's say, you know, I've got, you know, print old stuff. I want a backup of, well, I could comment this out, but the more code I have, like all this commented out code, it honestly makes it harder for you to work and be productive and read your own code. So what I will do all the time is, you know, let's say this is committed. I'll make a branch. I'll just call it backup. I'll delete that old commented out stuff. But now if I do want to look at it for any reason, it's on my backup branch. And that actually I do recommend. I think that can make your life a little easier. So after the break, we're going to look at connecting to GitHub and syncing with GitHub and stuff like that. We have a little cheat sheet that we made because this is a lot of stuff, and you absolutely can and should be using cheat sheets. In fact, I think it's not even the worst idea to print out a cheat sheet. But down here, all the way down at the end of today's lesson, we've got a nice cheat sheet of commands. We have a little bit of advice. Again, you can really paint yourself into a corner with Git. Don't do it. Just check in with a buddy, another student, a TA, an instructor, make sure you know what's working. We also have links down here, some intermediate Git stuff and sort of a bit more of an advanced cheat sheet for folks who are interested. So the plan is, and I apologize, I ran a bit long here, but we're going to break and we're going to come back at 11. So I'd like you all to take a break, like take a real break, because at 11 we're going to do more Git stuff. But like after you take a 10-minute break, take a look at this first assignment that we have for today's lesson, the Git practice one. And I would like you to get started on this now so you can get it under your fingers a little bit before we hit part 2. And after the break, if anyone wants to demo, you know, we absolutely can. And I'll be around in Zoom. So this is going to be our assignment between now and 11. And it's just creating a local Git repo, running some commands, and practicing stuff. So why don't we, let me quickly see if there's any quick questions that would be good to knock out. Then let's take 10, and then let's reconvene and work on this assignment. And I will create like a bunch of breakout rooms and stuff so people can be in Zoom, but we can also hop around and answer questions as needed. Does that sound good to folks? Awesome. And what questions do folks have? Tyler, yes, sir.
So just to, I guess, kind of like summarize to make sure I'm understanding kind of best practices. If you're, before you commit any changes, make sure one that you're on the right branch that you actually want to commit those changes to. And then if you're going to merge changes with your main branch, it should only be code that you know works that you want on your main branch, and you're doing testing in other branches that are not main. Is that correct?
Yeah, 100%. You kind of want to protect the main branch. Like we'll learn how to write tests actually that'll live on main branch. But yeah, the branches are for trying stuff out. It's also for collaboration, because if you're on a team of like 7 people, you use branches so 2 people don't touch the same line of code. For most of the assignments that you all will be doing for the next couple weeks, at least, you all will probably spend most of your time on the main branch and won't need to create lots of branches. What I recommend doing, and this is a really good question, make small commits. There are a bunch of studies about what senior engineers do. They actually make really small commits of, it could be even 2 or 3 or 5 lines of code. And just do little commits as you go. And that's what I would try to practice. Like, try not to have your commits be more than like 5 to 10 lines of code in length. And
Okay.
on a practical level, the usefulness will be, first of all, saving stuff to GitHub in case something gets deleted. And second of all, if you do end up like breaking some code and you do need to go back in time, you sort of seen that that's possible, and that you can reach out to an instructor or Francisco or myself, and we can show you how to do that.
Okay, so like using the example, like the challenge you and Francisco did yesterday, it'd be like before you made that helper function, you'd want to commit the main function you made, and then each kind of step of the code you're committing.
Yeah, pretty much. Yeah. Ideally, each commit should capture the code in a working state where like something works. But on a
Right.
practical level, when you're learning for the first time, honestly, I wouldn't worry about that too much. And in the real world, people they call them work in progress or WIP commits more often than we should. So it's not uncommon. Yeah, don't let Git be a barrier to being productive.
Okay.
Use it, learn it, but don't let it be a barrier. Saul, yes, sir.
I just wanted to ask real quick, just to clarify, every time you make the change, you want to git add and then git commit. But once you've already git add once, do you have to repeat it every time you want to commit, or can you just send it straight to commit?
Any change you make needs to be added and then committed. You can, yeah. So like if I change a file and I add it and then I change the file again, that's a new change. I got to add it again.
Okay, sounds good. Thank you.
Yeah, absolutely.